Hello and welcome to the next video. This is all in chapter 4 from our book. We're going to talk about if statements and Boolean values and logical operators, switch statements or case statements, all of that. I'm going to briefly and cover over the basics of each one and give you make sure that you have proper understanding of each one. Without further ado, we'll get into the very beginning. So if statement is the first level, the most simplest form of a decision structure is a plain old if statement. If, in my example here, if it's cold outside, if cold outside is equal to true, then what we're going to do is wear a coat, wear a hat, and wear gloves. And so here's the flowchart for that. We come along to the decision statement and check whether or not it's cold outside. If it's true, we take this path and we execute any amount of code that's over there until we come back to the original path again, or maybe this path never comes back. That's up to the design of the program, right? Maybe the false statement, if it's false, maybe that goes somewhere else. And then once we finish the if statement, the rest of the program continues to execute as normal. Okay, so we finish it and we just continue on afterwards. So all this code that's in here will only execute if whatever's here evaluates to true. Okay, that's a basic if statement. Okay, in order to kind of understand what we're going to put in here, let's talk about that. Okay, we're going to put Boolean expressions in there. A Boolean expression is something that will always equal to, it will always evaluate to either a true or a false, either a 1 or a 0. Okay, Boolean is named after this English mathematician, George Boole. Lived a long time ago. He's the namesake of Boolean expressions. Okay. He did some work with expressions that must always equal true or false, hence why Boolean values are named after him. Okay. What this means is that when you're writing an if statement and you're writing what condition goes in the top of that if statement, you have to write it in such a way that it is something that will evaluate to a true or a false. Okay. If it evaluates to something else that can't be converted to a true or false naturally in your chosen programming language, then you're going to get some sort of an error. Okay, and so a lot of the common ways that we will do this is with greater than and less than, greater than equal to, less than and equal to, or not equal to. These are relational expressions. Okay, they show how the thing on the left relates to the thing on the right. Is it greater than? Is it less than? Is it equal to? Is it greater than or equal to? Is it less than or equal to? And is it not equal to? Okay, these are very common in many if statements. You're going to use these a lot. Get used to them very quickly. Okay, the not is a little bit special because not by itself is it turns something into the opposite of what it was. So if something was true and you put not in front of it, now it's false. If something was false and you put not in front of it, now it's true. All right. So not is a little bit unique, but not equal to is simply not equal to. Okay, it's not going to make it the opposite. Not by itself does that, and we will get to that in 1 or 2 slides here. So Boolean values are going to be true or false. Okay, and I have here in Python most values will be true. So in Python, any number except 0 is going to equate to true. So if you leave a number in there, if you do some math and it turns out the answer is 5, and you say if whatever your math is and it turns out 5, that's going to be true because it's not 0. Only 0 is false. any string except for an empty string is true. Okay, and we've not gotten into lists and tuples and sets and any of that stuff yet, but except for empty ones, those will all be true, just like strings. Okay, an empty string is false, and you can probably guess why, because if you program an empty string, you think, well, if something's going to be false, that should be the thing that's false, right? Most values that do have content will end up being true, okay, except for specific ones like empty strings or the value 0, or empty lists or empty sets and things of that nature. So some of the things that will be false, okay, again, empty values, the number 0, the value none, and of course false with a capital F equates to false. Okay, this is not, as I have a note right here, this is not universally true in every programming languages. There are programming languages where only 1 is true, or only -1 is true, and all other numbers are equal to false. Okay, so you have to know which language you're working in and which values are true and which values are false before you can safely use those values in order to evaluate whether something is true or false. Okay, so you have to be aware of what language you're in. I've listed some values for Python here. That's what we're using in this class. If you're using a different language later on, you need to be aware of what those values are. Okay. Next, some logical operators and, or, and not. I spoke briefly about not already. Starting at the bottom, if it's not true, it's equal to false. If it's not false, it's equal to true. Okay, so a lot of tests and example questions are going to put not in front of something, have you evaluate it, and that not might trip you up at the end if you forget that not false is equal to true. Okay, that's a very common kind of a rookie mistake. It's not false, that equals true. Okay, and if something and something else, if I want to find out if that evaluates to true or false, and both sides must be true. If one side is false, it's false, all of it. Left side is false, right side is false, doesn't matter. If one side is false, it's all false for an and. Okay, an or, only one side or the other or both need to be true. Okay, as long as at least one side is true, the or is true. There's a short circuit for these. Okay, what that means is on an and an or, both of them, when I'm testing out and I'm evaluating, I'm going to do the left side first, and on an and, if the left side evaluates to false, my computer, my program already knows it does not need to check the right hand side, because an and requires both sides be true in order to be true, otherwise it's false. So if the first side I test is false, I know the entire thing is going to evaluate to false, and I don't have to worry about checking the second side. You can use this to your advantage for efficiency. If you think that one part of your equation is going to equate to false more often than the other part, you put that on the left-hand side, and then more often than not, you'll be able to skip the right-hand side. The same thing is true in the or, only it's the reverse. Okay, in the or, only one side needs to be true, and so if you evaluate the left-hand side and it turns out to be true, you can skip the right-hand side. It doesn't matter if it's true or false. You've done enough. You found that one side of it is true, and so the short circuit can skip that. And again, you can use that to your advantage when you're doing an or. If you think that one side is going to turn out to be true more often than the other side, you put that side on the left-hand side, and then more often than not, you'll be able to skip the other side. Okay? Moving on. Boolean variables. Okay, you can store true and false in a variable. And then the beauty of this, some of the beauty of this, is once you set in this case, once you set true to a variable, I no longer have to test if my variable equals true. I can just test if my variable, okay, because it's either going to equal true or false, of course. You can do this with numbers as well. Like we said, all numbers are going to be true except for 0. So I can say if this number is, if my variable that happens to be a number, and then it will only show false if it happens to be 0. Okay, you need to be careful with that, of course. Make sure you're doing your math or whatever other operations you're doing correctly, because if you have a lot of potential trues and only one potential false, that may or may not be something that you predicted. Okay, you need to be aware of that. All right, we talked about the simple if statement, and now we have the if-else statement. Okay, so the if-else, if this turns out to be true, okay, if your age is greater than or equal to 18, surprise, you're old enough to vote. Else, if this is not true, if you're not greater than or equal to 18, you're not old enough to vote. Okay, so very simple. Either this is true and the first section executes, or this is not true and the second section executes. Okay, what's very convenient about this versus just piling on a to if statement to say if this is true, do this, and then carry on, and then if this other thing is true, I don't have to write the opposite. Okay, without the else, I would have to write if age is greater than or equal to 18, and then later I would have to write if age is less than 18. And I would have to make sure that I write it correctly. If I had a very complicated statement in there, I would have to figure out what the opposite of that is before I could write it. By using the else, I don't have to figure out what the opposite is. I can just write else. That's very convenient. Okay, we can also use greater than, less than, and equal to compare strings. In many languages, this is the case. We can do this. It's very useful for putting strings in alphabetical order. So there's an example in the book that I've screen grabbed, is Mary greater than Mark. And what this is going to do is going to take the ASCII representation, or the ASCII value for each character, and in turn compare that value in greater than or less than. Okay, in this case, greater than. And Mary and Mark, the first three letters are all the same, so the M and the M are the same. It goes to the next one, just as you would if you were trying to figure out if two things were in alphabetical order. You would go each letter at a time, and in this case you'd get to the last letter, Y versus K, and Y's value is 121, K's value is 107, so you find out Y is greater, and therefore the entire string, Mary, is greater than Mark, and now you can put them in alphabetical order. You do have to write yourself a function to do that, of course, but you can organize strings, you can compare them, see if they're alphabetically greater than or less than one another. Nested decision structures. You can put multiple if statements inside of each other. So I have this fairly intuitive example right here. Okay, remember that in Python you do have to maintain your spacing. Okay, I'm kind of doing pseudocode right here, right? Because I don't need this end if. But I'm going to input my outside temperature, and then if it's cold outside, I'm going to execute all this code. And then inside this code, I have more if statements. I say, if it's raining, wear a raincoat, else wear a normal coat if it's not raining. Okay, this if statement ends, and then I've said, if it's really cold. Okay, so my first temperature check, maybe I said if it's less than 60. Okay, now I'm going to check, is it raining? Wear a raincoat. Is it, if it's not raining, wear a normal coat. Okay, if it's really cold, now if it's less than 50 or 40, now I need to wear gloves as well, because a coat by itself probably isn't enough. and then when I've done all of this, I can finally continue on with the rest of my program, and I can go outside. If it wasn't cold outside, I would just skip all this, and I would go outside. Okay, so you can put, and there's no end to this. The only end to how many if statements you can nest inside of each other is how much RAM you have in your computer, and how much of this program it can fit into your RAM. That's really what the limit is. Okay, so don't worry about how far down the rabbit hole you go with this. If you're writing a program and for some reason you require 782 nested if statements, if you can keep track of it, just go ahead and write it. Okay, I don't think that's ever going to happen, but there's no limit to the amount of if statements outside of how much RAM do you have in your computer. If you have enough RAM to run Chrome, you got enough. Okay, here's another little visual representation of nested if structures, nested decision structures. In this representation, again, I took a screen grab from the book. If a grade on a particular assignment, we're going to follow this program. It's important that you do follow programs step by step so that you understand how your own code works or how these examples work. So we start in here. If the score is less than 60, if that's true, display your grade as an F. Now, that's not going to be anybody here, so that's false, and we continue on. And we say if the score is less than 70, display your grade as a D. Still probably not anybody here, so that's false. And then we come over and say if the score is less than 80, it could be a couple maybe. All right, 80, that's not terrible. Display your grade as a C. Okay. If that was false, we continue on. If the score is less than 90, display your grade as a B. And if that was false, display your grade as an A. And then at the end of all of these, it continues down and it falls back into the main portion of the program. Okay, but let's take a look at this structure here. Most of the students, and I assume most of you, are probably going to have an A or B or maybe a C. So I'm going to have a lot of A's and B's, and this program is going to have to check for the F's, the D's, and the C's on all of them. Okay, that's probably not the most efficient way to write this. If I were to write this the other way around and first check to see if score was greater than 89.9, and then if it is, mark it as an A, and then check to see if, okay, it wasn't greater than 89.9, is it greater than 79.9? Okay, great, those are the B's. And now, probably, if all my students are doing well, I've tested most of them already with only 2 if statements, and then only a handful of students might need to continue on and have more if statements. Writing the program in this direction, bottom heavy or versus top heavy on all my if statements. If I have a lot of good students, a lot of if statements are going to run. If most of my students get A's and B's, and A's and B's is the last test in here, is for both A's and B's, that means that for most of the students I have to test 1, 2, 3, 4 if statements before I get their grade. If I reverse this, for most of my students I would only have to test A and B, and then I would only have to test 2. That's half as much work on my processor and my RAM and everything. Okay, so a little information about efficiency and ordering of your if statements. For the most part in this class, you don't have to put them in any kind of weird order. For example, if for some reason we had a lot of historical data and we knew that all the students' grades, the most common grade was 72 or something, we could organize these in some odd sort of order so that that grade is the thing that gets tested first. You can do these when you're really trying to get an efficient program and you have a lot of data that you have to be considerate of. If you have historical data, you can reorganize your if statements to test for whatever the most common thing is first, so that that thing gets the least amount of if statements in front of it. Okay, it's much more preferable to just choose either a top heavy or a bottom heavy. In this case, either start at the highest value and work your way to the lowest value, or start at the lowest value and work your way to the highest value. All right, once you start putting them out of order, if you didn't have a specific reason for that, you've just made it more difficult to read and more difficult to maintain in the future. Okay, so you need to have a specific reason to put them in a weird order. Just go from lowest to highest or highest to lowest then, most of the time. Okay, but try to be considerate of which direction may be more efficient. It's either going to be high to low or low to high. Okay, the last thing I have here is the case structure. Now, there is not a case structure in Python. We're going to use the else if or the elif ladder. And the way this works is we have our if, and we have our condition, and then we have our stuff that we're going to do. And then if that's not true, else if another if statement. If that's not true, else if another if statement. If that's not true, else if another if statement. And then a trailing else at the end is often useful for perhaps a default. If none of these things is true, I should probably have something to execute in the event that none of those other things happened. Okay? This is not a case structure. This is not a switch. It is really just a lot of if else, if else, if else, if else in a row. Okay? And what the difference is, and I have my next slide here, has an actual switch statement. Well, it has a representation of a switch statement in another language. Is you write switch, and this would be my expression or my variable. Let's pretend that this is, I'm going to do a switch on a grade. And then I say the case here, the grade is 90. Okay? And then I execute my statements here, and before I get to the next switch case, all right, it says I'm optional to break out of the switch. It is traditional that in each switch case, you execute whatever commands you're going to execute, and then you break out. Most of the time, that is what we do. We break out for each one, but you don't have to. Let's say that there are two cases where I actually want to do the same thing. I can put these two cases, and I don't break out of one, and if you forget to write the break, the same thing will happen. I won't break out, and I'll execute, and I'll keep executing all of the available commands until I reach a break, or until I reach a case that does not evaluate to true. So if multiple cases evaluate to true and they don't break, all of them will execute until either the end of it is reached or a break is reached, in either case. Okay, so you do have to be aware of that in a switch. By default, you're generally going to just type in breaks for everything. And if you don't, you'll run into the issue where multiple things happen. Sometimes you'll do that on purpose, and sometimes you'll do that on accident. Okay, so that is all the important bits from Chapter 4. Okay, that's the video. Thanks for watching.